Hi everyone, welcome back to a new video. Now after completing the important methods of arrays and the basic idea of what is arrays in Python, now we need to learn some operations that we can perform on an array, right? So one of them is searching, right? Means if you have been given a value and you want to search that in array, there are search algorithms for that. Okay, so we will be going through two important search algorithms. One is linear search and the other one is binary search. Okay, the time complexity for a linear search is O of n, and the time complexity for binary search is O of log n. Now why is that, we will see now. Means in linear search what do we do? Let's say it is O of n and this is O of log n. Now why is this O of n? In linear search what we do basically means we will be iterating through the entire array and we will check whenever we will find the equal value. Means let's say I have an array 2, 3, 4, 5 and 6. Okay, so I want to look for 4. Okay, and I need to return true if I find the value, otherwise I will be returning false, right? So in linear search what I will be doing, I will be iterating through the entire array and I will check that if 4 is present or not, and if it is not present, then I will return false, otherwise when I will find the number, I will return true. So we have started from 2 here, we will be going to 2, then 3, then 4. Now once I have found the value, I will return true. So this is like a normal case, but let's say in the worst case scenario where my value is at the end of the end of the array, or the value does not exist. Okay, so for that the iteration will be continued till the end of the array, right? And when we are continuing till end of the array, for that means our loop will be iterating till end, right? Therefore it has the time complexity of O of n in the worst case scenario. And let's say if you found the value at the first index only, right, on the first index only you found the value, then it is a constant space, right? So this is the basic implementation of linear search. Now how do we implement it? So according to what we said, we will have a loop which will be starting from 0th index and will go till less than n, and we will check, right, if the value, let's say the array name is ARR, if ARR at I is equals the target, whatever value that we are giving to check, if it is found, then well and good, we will return true. Otherwise, if we have completed the entire iteration and we are not getting any value, right, so after that out of the loop what we will do, we will return false, right? Now this is kind of a brute force method or a straightforward approach that we apply to search, right? And this is applicable for every array. Like it does not have to be in a particular sorted manner, or it should not be in a proper any, you can search in any element. Okay, means it can be in any order. There is not it is not needed that it should be either in ascending order or descending order, then only it will work. But when we move on to binary search, it has a time complexity of O of log n, right? Means that is it is like an optimal approach, but the reason or the main thing that is required for binary search is we need to have a sorted array, then only it will work. The entire working of binary search approach will work on the fact that the array is sorted and then only it will search. Okay, so let's say now I have an array 1, 2, 3, 4. Okay, and I want to search 3 here. So how does binary search works? It will first, let's take 5 elements in the array, then it will be easy. Okay, so let's say that we have 5 here. Okay, now I want to search for 5 here. So how does binary search work? In binary search we will take 2 pointers. Okay, so one will be on the 0th index, so let's name it as start index, and we will have one end index. Now we need to we will be iterating using start and end, and we will also have one index called mid. This mid will keep track of whatever value that we will be comparing. Okay, so how do we find the mid? We will find the sum of start and end. We will divide by 2. Okay, so we will divide it by 2. Now we have the mid value. Let's say as said, our target value is 5. Okay, so now we have found the mid value, so our mid will be here. Now what we will be checking, that if this value is equals to the mid value or not. Means if target is equals to the value ARR of mid or not. Now let's say our target was 3 only, just for an example. So our target was 3. Then we would have simply returned true from here only, right? Once we have found the value that is equals to the target, we will return true from here. So here we know that we need to return true once we find the target value. Now, like we have the target here, okay? We have 5 here. Now we know that this array is sorted, which means if our value is 3 here, right, that means my target value will be on the right side of the array, right? Means which is basically if I have an array, okay, we have 3 4 5 and 1 2. Now my array is sorted, that is known, and the binary value the mid value is 3, and whatever target we have been given, the target here is 5, which is greater than 3. Therefore this target will lie on the right side of the array. So what we can do here, I can move my start pointer here, right, and my end index will remain at the same position, but I can move my start index to here, right, on this index. Why do I do this? Because I know this part of array is not required anymore, as 5 will not be in the part of the array which is less than 3, right? So what we can do here, we can check a condition, else if target is greater than ARR of mid, then what we can do, once we have found the value that is once we have found the value that is greater than the mid value, that means my value will lie on the right side of the array, right? So there is no need of iterating on the left part of the array. I can just leave it out, and I can move my start pointer after this. Since my mid value is not equals to the target, so I don't have to consider this also. I can simply move my start index to the mid plus 1 value, because whatever value I will have will be lying on the right side of the array only. So what I can do here, I will simply change my start to end mid plus 1, right? Now let's say I have the target as 5 here. Instead of that, if my target was 1, okay, and I have the same array 1 2 3 4 5, for the first time my mid value will be here, and I will check if this value is equal or not. It is not equal. So again what we will do, we will check if target is greater than ARR of mid or not. Now my target is less, right? My target is 1. So this condition will become false. Now if my value is not lying in this part, then it will be lying in the left side of the array only. And since this mid is not equal, so I don't have to consider this, and my start pointer is already here, right? My start is already here. I just need to bring my end pointer before the mid, so that I can find the value between the start and the end pointer, right? So in the case where the value will be, the target will be less than ARR of mid, then what we will do, we will move our end index from here to here, because now we will not have the value on the right side of the array. we know that it will be lying in the left side of the array only. Therefore, what we will do, we already have taken care of two conditions. Now only one condition is left. For that, we will simply write else, and what we will do end is equals to mid minus 1. Now we have this we know the condition that we have to follow, okay, and we have found the mid value. Now we need to iterate it again and again so that we will be able to find the value. And when the question comes about iteration, since we don't have a proper we don't know the proper number of iterations, so what we can do, we will be using while loop here. It will be quite easier to use, that's why. And how many times we are iterating means, let's say I have we will use the previous one only, and I want to search for 3 here. So for the first time, 1 2, my start is 0 and end will be 2 and my target is 3. For the first time, what is mid value? Mid is equals to 1, right? And I will check if this is equals to target or not. It is not, right? And the other condition that we have here is if the value is greater than target is greater than mid value or not, which is true. Therefore, what will happen? My start will move from here to here, right? So my start will get updated to mid plus 1 and end will remain same, which is equals to 2. Now my start got updated to mid plus 1, that is 2 only. Now if I try to iterate more than this, I will be finding an error, right? What I have to do here, I will be finding the mid value again, which will be 2 only, and I will equate and I will find the value. That is fine, but there is a condition here, right? I cannot check the condition anymore. I have reached the condition here where start is less than or equals to 2 or start is less than or equal to end. So my while loop will be only continuing till the condition when start is less than or equals to end. Okay, so this is a basic syntax of binary loop. Okay, so here we have a linear search, and this is a binary search. Now let's move on to the code editor and we will implement this codes there. Okay, so let's see the code now. I will be mentioning this linear search and binary search question in the sheet, and you can try to solve these codes on your own. Now in this question we will be implementing the simple linear search that we have. Okay, so what we have been told here, that you have been given an array here, and it will have n number of positive integers, and you will also be given an integer x. For that you will have to search in the array if it is present or not, and if it is present you need to return the first instance of that array. What does that mean? Means, let's say I have the array given here 5 1 3 4 3, right? And what I need to do, I need to return, if I am finding the I need to return the index where I am finding this 3. Okay, first instance of 3. Here I am once I start iteration, I will see 5 1 3 4 3. There are two 3's in this question, right? And I need to return only one, and it should be the first instance. Means I need to return the second 2 from here. I only have to return the first occurrence. So what I have to do, once I find the value, I can return the index, I can break out of the loop, right? Now let's try to code it. Okay, so we will start from the 0th index and we will go till less than n. So we will go till length of n, and once I find that I have that value in my array, I will simply return the index from there and I will break out of the loop. I will not search for that element again. Why do we do that? Because we need to return the first occurrence of that number, right? If we would have been asked that you need to return all the occurrence, then you would have searched for all the occurrences in the array. But here what you need to do, you need to return only the first instance when that like target or the value is occurring in the array. So we can simply return the first index that we are getting and we can break out of the loop. So what we will do, if a at I is equals to x, then we will return the I from there. And let's say I have iterated through the entire array and I am not finding any occurrence of that number, so I will simply return -1. So now let's try to run it. So the sample test cases are passed. Let's try to submit it. So this code has been accepted. Okay, now in the similar way we will try to implement binary search. Okay, so in the binary search, let's see what we have been given here. We have been given an array A and it is of size n. Also we have been given a target, and if we are able to find the target in the array, we need to return -1. We need to return the index, otherwise we need to return -1. Okay. Also we must write an algorithm whose time complexity is O of log n. Here we have been given an array which is in sorted order, right? Means when, you need to understand this. If you find a question where you have a sorted array and you are asked to implement searching in any way, you should try to prefer binary search. Okay. Now let's say you have only random array, then linear search is fine. But if it is a sorted array, try to use binary search only. Okay. Now what we will do, we will implement the binary search in the way that we learned before. Now we will initialize a value start and end, and start will be initializing from 0 and end will be from the last index, right? So let's first take the length of the nums or the array. Yeah, so nums, and it will go till start from n-1, right? And here what condition we will give? While start is less than equals to end. After this, what we have to do? We will be taking the mid value, right? So we will take mid value start plus end by. Now we will check if nums of mid is equals target. If we find that if I am able to find, then what I have to do? I need to return that index, right? I have to return the index. So I will simply return mid. Now let's say my target is greater than ARR nums of mid. Now if the value is greater, that the target is greater than, I will move my start to the right side of the right side of the mid. So my start will become mid plus 1, or else if my target is less than the middle value, then what I will do? I will move my end to the mid -1. Now let's say I haven't found any condition where I have found, means I cannot find the value anymore. I cannot find the value anymore. So out of the loop I will simply return -1. Now let's try to run this. So all these sample test cases are passed. Let's try to submit it. So this code has been accepted. That's it for today, guys. Thank you for watching. I hope I was able to help you out in the searching algorithms. And if you found this video helpful, please let me know in the comments. Also, if you have any doubts regarding to the searching algorithms, let me know in the comments too. I will try to help you out. And in order to continue with me in this coding journey, please subscribe to my channel and hit the bell notification so you will be notified every time I post a new video. Thank you for watching.